In this video, I'll introduce you to tex2solver, a free online tool that I've developed to help make life easier for anyone who solves linear or integer programs. Hi, I'm Doan Lee, a graduate student in Industrial and Systems Engineering at the University at Buffalo. I'm excited to share tex2solver with you. tex2solver automates the process of getting from here, a beautiful linear or integer program, to here, the programming code to actually give you a solution to this problem. tex2solver aims to support CPLEX, Gurobi, and other popular solvers. Let's see how tex2solver works. Suppose I found an interesting linear program in this document and I'd like to solve it. First, I'll start by opening tex2solver.com. I'll log into my free account, and this will take me to the tex2solver dashboard. Here is where I'll provide the model as an input. tex2solver generates solver code from LaTeX. But what if I don't have the LaTeX code for the model, or if I don't understand LaTeX? No problem. We can get the LaTeX code from a screenshot of the model. First, we'll click the Load from Image button. Note the keyboard shortcuts for your operating system. For Windows, it'll be Windows Shift S. I'll go to the document containing the LP model and apply the keyboard shortcuts to allow me to grab a portion of my screen. On the Mac, I'll use Command Shift 4 to do this. Highlight the model while holding the Control button on the Mac to save the screenshot to the clipboard. I'll now return to tex2solver and paste the screenshot that I just copied. And here's the screenshot. I can crop or rotate the image if necessary. Now I'll click the Convert Image to LaTeX button. Here's the LaTeX code for that IP model. I got a warning in the dynamic editor. tex2solver needs to know exactly where the decision variables are defined. I can click on the help link for more information. tex2solver makes it really easy to fix this. Simply click the Mark Decision Variables button. Now click on the line number where the first decision variable is defined. Click Stop Marking. Note that our LaTeX code is now rendered. It looks good. Now, let's generate the solver code so we can get a solution to this problem. We'll need to choose a solver type. Right now, PuLP is the only option. Support for other solvers is coming soon. We also need to choose a solver language. Python is currently the only option. We hope to add other languages to the mix shortly. We'll click the Generate Solver Code button to get our result. And here's the Python code that will solve the problem. We can email this to ourselves or save it for later. But I want to solve this one now. So I'll click Copy to Clipboard. I'm going to open a Python Jupyter notebook, but I could also paste the code to a text file and run Python through the command line. We'll paste our solver code into a Jupyter notebook cell. Then we can run the notebook. And there it is, the solution to the problem. And I didn't have to write a single line of code. tex2solver is designed to support numerous different types of users. Academic researchers, for example, tend to have a common workflow. We often start by developing a model and documenting this in Word or LaTeX. Next, we rewrite this model in a programming language so it can be solved with CPLEX or Gurobi. The original model usually goes through a series of revisions as we solve sample problems and revise our formulation. At this point, the original model and the solver code are no longer in sync. So, we have extra work to do to make sure our model and our solver code are consistent with each other. With tex2solver, we can make revisions to the model itself and regenerate the corresponding solver code automatically. For example, I'll start by copying a model from a journal paper I'm writing in Overleaf. I'll paste this LaTeX code of the model into tex2solver, check the rendered LaTeX, then generate the solver code. After generating the solver code, suppose I realize that I actually wanted those decision variables to be binary. I can go into the editor and make this change. I'll delete greater than equal to 0 and write instead in the set 0, 1. I also discovered that I forgot to add a constraint. Let's add this in. Notice I am writing this above the deck bar's label. Anything after the label must be a decision variable definition. Now that I've completed my changes to the model, I can regenerate the solver code. When I'm done, I can copy this model back into my overleaf document. Now, my revised model and the solver code are in alignment. For students who are starting to learn the basics of linear and integer programming, understanding the syntax of solver programming can be overwhelming. Translating from a formulation to solver code can also lead to errors, which are often difficult to detect for novice programmers. This process can be time-consuming and frustrating. Tex2solver helps students focus on modeling and solving problems. For example, suppose a student would like to explore a problem found in a textbook. With tex2solver, the student can select the Load from Image option and simply take a picture of the model using their smartphone. They can crop the image when necessary to capture just the model. The image will be converted to LaTeX code and then will appear in the editor. As we've seen before, click on Mark Decision Variables and then click the first line of the Decision Variables section. Then, from a laptop, the student can run the Python code to get a solution to this problem without having to write any code. Tex2solver also helps practitioners quickly solve those back-of-the-envelope problems, literally. From a smartphone, you can take a picture of a model you wrote in a notebook, on a whiteboard, or, in our case, an envelope. Once again, we'll select the Load from Image option as our input, choose Image, then select the option to take a photo. Let's take the photo of the linear program written on our envelope. The image looks good, so we'll click Convert Image to LaTeX. And then we can view the code in our editor. Next, remember to mark the start of the decision variable definitions using the Mark Decision Variables feature, like so. Finally, make sure to check the rendered model looks correct, and then proceed to generate the solver code. The solver code can be saved for later, or it can be emailed to you. Either way, you can then run the solver code when you log in on your computer. Let's talk a little about some tex2solver details, starting with the options for providing input. This is step 1 of the process. The key thing to remember is that tex2solver understands LaTeX. Fortunately, there are several ways that we can provide the LaTeX code to tex2solver. First, and most obviously, we can simply paste the LaTeX code from an existing document. This works great if you're writing a paper in Overleaf, for example. Second, we can load an image of a math model and convert that image to LaTeX. If you use tex2solver on your phone, you take a picture. On your computer, you grab a screenshot. Let's take a screenshot of a linear program from Wikipedia. We'll use tex2solver's Load from Image feature to convert our screenshot to LaTeX. One word of caution. There's currently a limit on the number of images you can convert each month. Another way to provide input is to open a model you saved in tex2solver. We have also provided some example models that you could open to get started. Finally, in case you ever hit your limit of monthly image conversions, you can use the Snip app from Mathfix. This is a great tool for converting math to LaTeX. In fact, tex2solver uses Mathfix OCR API to translate images to LaTeX. Regardless of the input method, tex2solver requires LaTeX code to be formatted with some specific characteristics. Fortunately, these are pretty common for LP and IP formulations. We've really tried to make tex2solver as user-friendly as possible. Each LaTeX representation of a model needs to include these 5 elements. Let's look at each one. The model should be wrapped in any of these math environments. You may also use the starred versions of these environments to hide the equation numbers. This is purely cosmetic, and it won't change the output code. The first line of the formulation must be the objective function. This should indicate if this is a maximization or minimization problem. The first constraint should appear on the next line after the objective function. This constraint should begin with one of these LaTeX tags. Decision variable definitions should appear after the constraints. The block of decision variable definitions must begin with this LaTeX comment. This line is most likely the only new element that doesn't already appear in your model. tex2solver makes it really easy to add this to your model. Note that this line is a comment, so it won't appear when the LaTeX is rendered. Finally, tex2solver needs to know which elements of your model are decision variables. Each decision variable should be explicitly defined after the deck bars comment. tex2solver supports continuous, integer, and binary decision variables. There are several different ways to specify each of these. tex2solver has a dynamic editor that helps new users by identifying errors and other minor issues. This dynamic editor provides feedback as you type. For example, suppose I misspelled max in my objective function. tex2solver gives me an error message. The dynamic editor also gives suggestions that can help users get acquainted with LaTeX. For example, suppose I use two periods to indicate a continuation in a sequence of indices. Clicking on the warning message will bring up a detailed help document. Note that as long as I don't have any errors in my model, the LaTeX code will be rendered at the bottom. After you provided your model in step 1, the second step is to generate the solver code. tex2solver currently uses PuLP as a solver API. One great feature of PuLP is that it allows you to use several different types of solvers, including Gurobi and CPLEX. The Python code produced by tex2solver has these options commented out, but it's easy to edit the code to choose a particular solver that you have installed on your computer. After the output code is generated, you may copy it to your clipboard, so you can paste it into a Jupyter notebook or text file. You may also email the code to yourself or save it on the tex2solver server for later. We realize that there are lots of different ways to specify an LP or IP, and every user has their own unique style when it comes to writing a model. We've designed tex2solver to be as accommodating as possible. Here are just a few of the special features that are supported. Overloaded summations allow the specification of multiple indices within a single summation symbol. Similarly, overloaded decision variable definitions allow multiple variables to be defined in a single line and with multiple indices drawn from a single set. Conditionals for specifying set membership are supported. Within summations, substacks may also be used to specify conditions. tex2solver also handles sets defined by non-consecutive integers. tex2solver is still in its development phase, so there are some limitations. For example, tex2solver currently only outputs Python code. Support for other languages is on our development roadmap. The current solver syntax is written for PuLP. PuLP is super easy to install, and it actually lets you use lots of different solvers. So, in a sense, tex2solver already supports Gurobi, CPLEX, and others. In an upcoming release, we plan to provide native support for more solvers. Decision variables must be explicitly defined using the deck bars flag in the LaTeX code. However, we should all be including these in our models anyway. Translation from handwritten models isn't always accurate. We use a third-party API to do the image to LaTeX translation, so much of this is beyond our control at the moment, but this should improve over time. Finally, users are currently limited to 15 image to LaTeX translations per month. We have to pay for the third-party API, so this limitation can be overcome if we have some sponsors. We are working to overcome these limitations, and we'd love to hear from you if there's something we're missing or if you want to become a sponsor. I hope that tex2solver helps make your job easier. You may sign up today for a free account at tex2solver.com. After you start using tex2solver, please let us know how it's working for you. We'd also love to hear your requests for new features. You may also follow us on Twitter, where we will be posting helpful tips and tricks. Thanks for watching. Happy optimizing.